Kobe, how are you? Gavin, how are you? Good.
Hello,
Hello.
Mr. Richards.
Hey, Bryce, how are you?
Good.
Good. Is your sister joining us today?
Probably. Kirsten, are you joining? She says she will.
All right. All right. I'm going to share part of my screen here. All right. So what I shared with you is the mystery class submissions that we got. And if you look closely, we got 5 of the 10 cities correct.
Yeah.
8th grade got 8 of the 10 cities correct. So hoping for better, but the concerning part is these blank rows. There's 3 of them that I didn't get cities from 3 of you. Now, that's kind of a major grade. I'm not gonna pull any punches. It's a very major grade. This was an activity that we started before we went home for the spring break and stuff. It started like in hey Taryn. We're talking a little bit about mystery classes. So as a class, we got 5 of the 10 right, but we're still missing 3 submissions. And it's a project grade, and I need something in from all of you. I don't think you can get a passing grade without getting those things turned in. Now, the answers are already out there. So I can't really give you credit for finding the cities now because all you have to do is, internet search or go to the Journey North. I will give you still some partial credit for the data charts and the graphs. And then any additional credit that you'll need to pick up, you'll have to do probably a project or so on explaining the clues a little bit, like the city continent clues, but we can talk about that later. But if you have something, those 3 of you that don't have a grade here for mystery classes, right? Or if you look in Power School and you see that it's missing, or you have maybe a 17% or something in this class, that's probably the main reason, is I don't have mystery class submissions, which it was really important for you to turn that stuff in before the answers came out. And I sent you countless emails telling you when the answers were going to come out and when the deadline was and when I had to submit, and still I got nothing from 3 of you. So we will talk about it later, I guess. Right now we're going to move on. Let me stop share. Any questions over that, first of all? Okay. It shouldn't have been that difficult of project for some of you that it apparently was. I wasn't thinking it was, going to be that difficult. I mean, there are classes that are 3rd, 4th, 5th graders that do this same exact activity worldwide and don't have some of the problems that we've encountered here. So I really expected answers from some of you. We are going to look at the interactive. So if you go to Explore Learning and launch the interactive on phase changes. I think you all signed up for an account. So I'm going to share my screen. So if you don't know how to get there or don't know what we're doing, you can try to follow along. Hey, that's what I want you to open up is the phase change on the Explore Learning site. Open up the gizmo. And this is the worksheet that's on Google Classroom. Get to the fill. Okay, everybody there okay? Any problems? What, Bryce?
I might be there. It's loading, but I'm not sure yet.
Hey, can you find the worksheet?
I am there, I think. I got the exact same type of thing you have on your screen right now.
Okay, so I have the worksheet open and I have the gizmo open.
The worksheet.
Okay, so you should try to have both of them open. If you can
Oh,
only
you
have
got
the,
it open.
if you can only have the worksheet open for right now, that's fine because we're gonna work on it together.
No, I got it all open.
All right.
Flip it, then it's on the top. No.
Okay, so prior knowledge questions. We do this before the gizmo. A family from Minnesota turns off the heat and flies to Florida for a winter holiday. All their water pipes have burst. What do you think happened? Bryce?
I think that the water got stuck in it, froze, and then froze so much that it broke the pipe.
Okay. So the water froze.
We don't really know where they live, so.
Well, it says they're from Minnesota, which is cold.
Okay.
Go ahead.
I think that since the water was melting because the heat, when they turned it off, since it got so cold so fast, the gutters couldn't handle it and they just broke open. Because I heard that happens with glass.
Okay. Yeah, a lot of times, like when it's cold, you might turn off at least your outdoor water or any water pipes that are close to your foundation so they don't freeze.
Mama, you can have it now. I don't need it anymore.
Hey, something along that line. Hey, this is a little bit harder. Spaghetti takes about 9 minutes to cook at sea level, but about 14 minutes to cook in the mountains. Why do you think this is so? Taryn?
Because of the altitude.
Okay. Bryce?
Maybe because up in the mountains it's colder and it takes longer for stuff to heat up.
Okay. In the mountains, actually what happens is water boils at a lower temperature. So to boil water, it doesn't have to get to 100 degrees.
You like that? On your sandwich. No,
Well, and we know something, if you know something about water, once it boils, it's not going to get any hotter. Once it boils, you put a thermometer in boiling water, the temperature is not going to go up after it starts boiling. Doesn't matter if you leave it on the stove for 10 minutes. It's going to go to the boiling point and then stay constant. So in the mountains, water boils at a lower temperature, so it's not going to be as hot, and it's going to take longer. All right, going down to the gizmo warm-up. Okay, so in the phase change gizmos, select microview and set the ice volume to 50. So in this gizmo, select microview. Right now it's in macro, so microview is down here.
Jeez.
I set the ice volume to 50, so ice volume. Notice the nitrogen, oxygen, and water molecules. Click play and observe the water molecules in the solid, liquid, and gas phases. In which phases are the molecules held rigid? So if we click the play button, in what phase are they held rigid? They don't move a lot.
solid.
In the solid, right? In the ice cube. And where were these things moving a lot? In what phases the molecules move freely?
Yes.
Yes. Okay, in what phases are the molecules held in a definite shape?
Liquid. Right?
Right? Well, both in a solid, right, and in liquid, they're always in the same. You might put and in which phases do the molecules take the shape of their container? There's where I would put liquid. Okay, activity A, get the gizmo ready. Click reset, pause it first. Click reset. Set the water temperature to 10 degrees. Set ice volume to 0. Okay, first it says to predict. So based on your prior knowledge, predict the following. At what temperature will water change from a liquid to a solid? When does water freeze?
32.
Okay, let's go Celsius though. What's the freezing point of water on the Celsius scale? Yes, Macy?
0.
Oh, I thought you were saying okay.
Oh, it's right there.
0. Now you can put the degree sign on your paper. It's option 0. Okay, at what temperature will water change from a solid to a liquid? What's the melting point? Bryce?
Isn't it like 122 or something?
Okay, let's go Celsius.
Oh,
Anybody? At what temperature does ice need to be for it to melt, turn to water?
50 degrees Celsius. Huh? 50 degrees Celsius.
32 degrees Fahrenheit, 0 degrees Celsius.
Yeah, 0 degrees Celsius still. So water melts and freezes at the same temperature. And Celsius scale, boiling point? Macy?
I'm thinking. I was gonna tell you Fahrenheit.
Richard.
Anybody? Can you tell me now?
32 degrees Celsius.
Okay.
Wait.
How about Celsius? Not 32 is like freezing point.
Oh, 100.
There you go.
Sorry, I was looking at different things.
No, shame on you.
So it's what?
It's 100 degrees. It's boiling point on the Celsius scale. All right, so now it says to use the gizmo. So use the gizmo to explore these phase changes. Use add, remove energy slider to control the water temperature. Record your observations. So we're looking at the freezing point. Move you guys out of the way. Shoop. I can't do that.
Richard,
Yes.
can you let me have access on my paper?
You don't have access on your paper?
No, you have to let me edit it.
You should all have your own copy.
I know, but I already turned it in.
Okay.
I already did this. Argentina.
A long time.
Very interesting.
Okay. So if I remove or add, let's take heat away. I can cool it down. And there at 0, we can see some ice forming.
I still can't do anything on it.
Really?
Yeah.
can you make a copy of it, and then when you're done with it, just like send it to me in an email?
I don't know.
You should try that. You don't have like control, like you can unsubmit it yourself?
No, I don't.
Okay, so as this is heating up, we don't see any water escaping yet. There goes the first one. Right. So 100 degrees Celsius. Nice, is that you making all the racket?
No.
Okay, Taryn.
Reagan, if you just unsubmit it, you
I
can.
figured it out.
Oh, okay.
Because it didn't let me unsubmit it, but I went into it like 10 times and it finally worked.
Okay.
So from the gizmo, at what temperature did the water freeze? That was 0 degrees. Ice melts. Okay, set up the gizmo to observe freezing. What do you notice about the temperature while it in the process of freezing? So if we start taking heat away from here,
Oh, that's cool.
okay, so now it's freezing. What do you notice about the temperature once it's freezing? Is the temperature still changing?
Oh.
No, right? It stays constant. Right? Temperature change while the other phases are occurring. So now we heat up and we melt the ice first of all. First of all, you'll see that the temperature is still the same, still 0 until all the ice is gone. Then it starts to warm up. And once we get to the boiling point, this is like if you left it on the stove forever, your water's not going to get any hotter, hopefully. Stay at 100 degrees. Now we have a lot of water escaping, but our temperature is staying the same. Okay, interpret, select the graph tab to see a graph of the temperature versus time. Click the dash button until the graph is visible. Okay. Let's. Can't control it. Oh. Okay, so here you can see the graph staying constant at 100 degrees, flat horizontal line. So during a phase change, the graph stays horizontal. Hey, why do you think temperature does not change during the phase change? If possible, discuss your answer with the teacher. So why don't we have a temperature change during a phase change? Anybody?
Because the temperature's staying the same.
Because why?
Because like it's in a phase, so like if it gets hotter or colder, it won't change it at all.
Okay. So what's actually happening is all the energy that if we're trying to boil water, all the energy is being taken up to evaporate the water, so it can't warm up the water anymore. And it's not being used to like speed up the molecules anymore. Okay, activity B. Select reset, select microview. Hi. We're about out of time. We'll let you work on that. Let's see. I'm going to stop share here for a second. Okay, when we end today, I'm going to keep some of you on for a little while, talk about some stuff. So here in about a minute, I want Kobe, Gavin, Bryce, Kirsten, Zane, Keaton, and Taryn to stay on for a bit. Okay. Looking at the checklist, keep working on that gizmo, see if we can get it done. Also continue working on Amplify 2.1. We meet again tomorrow, so let's not have anything exactly due until maybe after tomorrow's class. We can figure out the gizmo a little bit more if we're struggling it. All right. So any questions on that? All right, so if I called your name, I stay on for a bit. If I didn't, have a wonderful day.